do compounds containing carbon and hydrogen bonds typically form polar molecules? Okay, good question. Now, this one is really important. So, mainly because one of the most probably omnipresent, SAT word, but the most overall bond that you will see throughout your whole, science career, right? Chemistry, organic chemistry, especially biochemistry, physiology, if we're going into a little bit of, the bio side as well. You're going to see the most carbon-hydrogen bonds out of all the bonds that you will see in your life. So this is pretty important. Carbon and hydrogen bonds is the basis of life. So anything that's living has carbon and hydrogen bonds. So we are one big carbon and hydrogen bond. Fun. But anyway, are these bonds typically polar bonds? Do they typically form polar molecules? Well, let's see. By definition, if something is polar, right, that means that it has polarity. So we could say polar, they might say something about polarity. But it's all these P words, right? If you have a polar bond, if you have a polar molecule, you have a pull. So all these PP words. Which means that there is a greediness in the atoms. There's a greediness for electrons in the bonds. Nobody cares about what's going on around the bonds, but it's only the electrons in that certain chemical bond. So in this case, we have carbon and we have hydrogen, right? And the question at hand is what's going on with those two electrons in the single covalent bond? Well, you have three possibilities. One, the electrons are shared evenly. In this case, there would be no pull. But if one atom is greedy, maybe carbon's greedy, it's going to pull the electrons more closer to it in the shared bond. And because of that, we would classify that as a polar bond. The other aspect would be the other way. If hydrogen was more greedy, hydrogen's going to pull those shared electrons and go, I have them more of the time. There's the pull and there's the polarity. So no matter whether it's pulled towards carbon or pulled towards hydrogen, you have polarity. But if it's right smack on down the middle, you have no pull, and that would be nonpolar. So that's the different covalent bonds. You either have a polar covalent bond, which shows that you have the pull, and if you have a nonpolar covalent bond, that means that there's no pull. So no one's really that greedy. Now, if you're talking about a nonpolar bond, this is based off of electronegativity differences, just like polar bonds are with electronegativity differences. If you have a nonpolar bond, just know that the general electronegativity difference, electronegativity is the property in which we can find out if an atom is greedy or not, if it has that attraction towards those shared electrons. Electronegativity difference of 0.0 all the way up to 0.4. So these numbers are not that great. If you have a nonpolar bond, you're only allowed up until 0.4. Electronegativity values have no units. It's just kind of like used as a ratio value. If you have a polar bond, you have an electronegativity difference from 0.4 up until 1.8. So you have some leeway here. But as you see, the higher the number you go, the more pull you have. So we could take a little bit, look at the electronegativities on periodic tables. So yeah. Okay, so here's my periodic table that I have made for you guys. This is specifically the electronegativity periodic table. And just know that the electronegativity values are the lower numbers. Okay, so they're not the same as the atomic numbers, which are up above. Now, we just need to know for carbon and hydrogen. Now, carbon and hydrogen are both non-metals. They are in orange. Orange on this periodic table are our nonmetals. And this is up for discretion. Hydrogen, usually in textbooks, are 2.1. However, they have recently, the chemistry community has recently changed the electronegativity of hydrogen to 2.2. So I'm just using the updated number. But either way, whether you use 2.1 or 2.2, you will get the same general answer. Carbon is 2.5. So let's head on back to the problem and use these electronegativity values. Okay, so we did say that carbon was 2.5 and hydrogen was the updated 2.2 electronegativity value. Now, carbon is a little bit more electronegative than hydrogen, but let's see if it's going to break the bank. If we subtract these two values, right, 2.5 minus 2.2, I do get a 0.3 electronegativity difference. Electronegativity difference of 0.3 isn't gonna, mess things up. It's right in between 0 and 0.4. So this one would be classified as nonpolar. So this is a nonpolar bond, which means that there generally is no pull. The atoms are basically very, very, very similar. So the electrons are just chilling. It's an equal amount of vicinity to the carbon and to the hydrogen. So would these bonds typically form polar molecules? Absolutely not. Chances are they would form nonpolar molecules if it's just C and H. Nonpolar molecules instead. And going based off of what we said before, if we are just one big CH bond, right? We just C and H bonds all throughout us, right? We would be pretty reactive if we were polar, right? If we had those electronegativity differences. We want to be chill, right? Chill out. So the basis of it is that they form nonpolar molecules in general if it's just C and H. So the answer for this is no. Hopefully this helped. Thank you so much for viewing the video. Let me know in the comments if this helped you out. Subscribe to the channel, like the video, tell your friends, right? We also have a website. My brother and I, we have a website just designated to practice problems like these. So if you aren't on the website, I highly recommend you going on over there, glazersguide.com. The link is in the description and it'll be at the end of the video. And yeah, tons of practice, tons of fun, and we get to hang out. Win-win, all right? So I hope to see you on over there, and I hope you have a great day. Okay, bye-bye.
For more practice and for more fun, go to glazersguide.com.
And for more practice and for more fun, come on, go to glazersguide.com.